Okay, let's sorry about that. Let me continue where I left off. Okay, so it literally opened the DLC Nuka World texture file. So that's the one we want to look for. All right, so let's go back over to our data folder where our game is installed. And what we're going to look for is Nuka World DLC. Give me 1 second here. And I wonder if it's up. What is it called? What's the specific file? Okay, it's under DLC. All right. DLC, right? Which one? Let's get DLC Nuka World, so it's going to be up here. All right. Okay. So here's Nuka World. Here's the texture file. So this is basically what I opened here. And like I say, that's really all that function does. I provided a very limited definition for that file format, and then I told my program, here's the file, here is a very limited definition, parse what you know. And that's basically what it did to bring up this file list. But I'm going to show you in this file where that information is. So let's go in here and let's open this up. Just like we did before, we're going to use hex editor here. All right. So again, you can see the file is a BTDX. So we know by looking at that format is associated with Fallout 4. Maybe even Skyrim Anniversary Edition, perhaps. It's probably going to be a new format. To me, it's a better format than the previous formats. It's cleaner. It's more direct. And it's a lot easier to work with, I think, than the old formats, because the old formats had folder name, and in order to decrease the amount of data that was stored inside the file, they wanted to remove as much redundant information as they could. So instead of putting the full path on every file name, they basically put the path and then the file name separate. So you would have to load the path item for, like the path item, and then beneath that, quote, in programmatically speaking, beneath that path item, you would have a list of all files in that path, and then you would go to the next path. So it was a way so that let's say you have a file, let's say you have file 1, let's say you have 10 files, like file 1 through file 10, and they exist in data character np data slash character slash npc slash, so it's a lot of text, and you had to repeat data slash npc texture data, data texture npcs, all that. You had to repeat all that 10 times. But the only thing that changed was the file name of file 1, file 2, file 3. You want to get rid of that redundant information. So you're going to have a single entry that says like texture, data, NPC, whatever. And then underneath that, you're going to have just the name file 1, file 2, and file 3. And you need to put both those pieces of information together to find out the actual name of the file. And that's kind of the way they used to do it. Now, they just put the full file name in, but they put the table at the end of the file. So if you go to the end of the file here, you'll actually see a list of all the textures. See, you have textures, and you'll notice this little period here. This little period means the text editor, the hex editor, does not know what that is. And what that is 2E is the size of the text string. I believe it's not a Z string, would be 0. It's a W string, I think, or a B string. This is a B string. And I know that sounds really funny, but a Z string means that a text string ends in a null value of 0, 0. A B string means that the text string is preceded with a single byte that tells how many characters are in that string. So we have 2E, right? So let's go over here and let's convert 2E to decimal. So it's 46 characters. So if I'm taking a look at 2E, which is right here, there should be 46 characters before it gives me the next B string. And the B string is byte, it's the size of the string in byte and the number of characters. So they should be exactly the same. So if this says there's 46 characters, there should be 46 characters in this name. I won't count them off, but that's what it should be. Otherwise, the file names will be all messed up because you'll be grabbing files in the middle. You'll have byte values which are not ASCII text. I think I got rid of the table here, but it won't be ASCII text, so it's going to be erroneous. But what you can do, I'm going to show you another things you can do is to break apart this file. What I did was I looked at the data, and then I thought, okay, how far in this file do all these textures begin? Okay, so let's take a look at texture, and the files begin somewhere up here. So I'm not sure how far up it is. I'm not sure what files come first. But let's see if we can get in the general ballpark, and let's see what we can find, because what we're looking for is some kind where this data actually starts, just to kind of show you what I did, at least. And it's like a quick and dirty thing. It wasn't anything major or anything like that. Let's try this. This is going to take a while. Alright, let's see. Let's see if we can keep buzzing through this. How about if we look for... let's see. Okay. So it looks like... Okay, so what I did was I found what I believe to be the first name in this table, this index. Right, remember, so all of these files, now remember, it doesn't care whether it's a texture file like a DDS, a mesh, a script. It doesn't care. It just knows that this gigantic file has a bunch of little files in it. So you open the big file, then you open all the little files and write all the data from the little files into the big file. But you have to keep track of where in that big file that little bitty data file begins. And that goes back to your indexing. It's the name of the file. Now, you could put the name of the file right before the file, but you would have to parse the whole thing out and then calculate your offsets into your data file in order to extract just that one file you need. So this is just another way of indexing it. So I found what I thought was the beginning of the name table, okay? And then I looked at the offset. This is the offset in hex. So then I went to the beginning and I looked for something that represented that offset. Like, let's say something like this. And I said, okay, this is the pointer to the name table. So I take wherever I'm at. It could be the excluding the header data, or it could be relative to the end of the header data, or it could be relative to the beginning of the file. And then I took that, I added that to, didn't add it. Well, if it's a header, you have to add it to the header position. So like if the header starts at position 100, you'd have to add 100 decimal and then figure out what the hex decimal is by converting it over here. And then that's how I found the pointer to the name table. So what I do is open the file. When I do this kind of function, it's pretty easy because all I do is open the file. I open this texture file, which is a BTDX. I then say, okay, I know so many bytes in is a pointer. It's an offset into that file, which lists all the names. I know the name by looking at the data here. I know the actual file names are bstring. So there's a byte in front of the name that actually tells how many characters that name is. Let's go all the way down to the end here. That tells how many characters that name is. Okay, which is, I believe, here. This looks null. It looks like null terminated to me, which is like here. So it tells how many characters this is going to be. Now this looks null terminated to me, but the rest of them are not null terminated. So, all right. So here, and that could be, I'm not sure what that is actually, but that's what I did, and I grabbed. So I said, okay, this is so many characters. Actually, this looks Z-string. Interestingly enough, that looks Z-string because that is a null terminator there. This right here looks like a W string, like a word string, as opposed to a B string. That's what that looks like. This looks like W string, word string. So there's 2 bytes for the size of the string. That's what that looks like. So that would be W string instead of B string. So I looked at that, know what the format is, and then I just simply extract the names. These are also associated with files. The actual files start up here. And you can tell that the very first file should be a DDS. Here's the second file. It's a DDS. So this DDS file is small. It's small. So, and it would be, if you keep going, we might even find NIF. Let's see. I've never done this, but let's take a look. So it looks like we have a NIF in here as well. So maybe that's additional NIF files. How about XML? Let's take a look at that. That's another format. That might be an XML data chunk. So when you look at this, you can see it's just one giant contiguous block of data. But actually, it's many different files all crammed into one, and you need some way of being able to figure out where those individual files are so you can extract them. And that's what that is. And that's all that is. So you can use a little application like this to take a look at the files if the mod author doesn't provide you with something. And you can also use it to look at NIFs, like I did before with the little, let's see, let's go back up here. I think it was like it's not a sunspot, but like a lens flare or something. You can actually take a look at it. Let's take a look at the meshes again. Let's take a look at actors. This is probably going to be way different because I have no idea what this is. But let's see what it looks like. Okay, so again, there is a lot of information in here. I'm pretty sure there is, I think it's a BGSM is a material file. Here points to material file. So literally what you could do is you could load, and I've done this, and you can load this whole file as an ASCII text file. And you can look for certain file extensions, like BGSM, because regular data that's not a B, that's not a G. So you just skip it. You find BGSM, and then you start grabbing a single byte backwards. So like, let's say you're looking for BGSM. You find it. Now you start from here, and you start going backwards until you hit a character that is not displayable. And then once you do, you know you found your file name because there's your file name. And that's what you extract. It's very simple. You don't even have to know the format of the file. You don't even care. You don't even know what the data is. You don't even have to parse it. You just look for file extensions, and then you extract the file names. And then once you do that, you can then take them file names, which are relative. And then you can say, do I have this file installed on my system? And you can, again, do that programmatically. Is that file a loose file? So you put your installation folder /data / that relative name. Does that file exist? Is that a loose file installed? No, it's not. Okay, you can actually look in other BA2s, just like I showed you how to extract the names. Very easy. You can look at that and say, does that file exist? I don't have it in any BA2, so that is a missing materials file. It is a missing texture file. So you can do very simple kind of edits, or I don't want to say edits, but oh Lord, what am I looking for? Oh man, validation, if you want to call it that. Just file checks to see if you have what you need. And it can be done very simply, very easily in any language you want to use. You can use C++, C#, you can use VB. It's whatever you want to use to do that. It just takes a couple lines of code. But I wanted to show you guys that to kind of show you where the information's coming from, and that you don't have to be some kind of super programmer or anything like that to be able to load a file up in HexEdit, take a look at it, look for certain things. And then once you get more advanced, or if you choose to do it, you can start learning what all these data formats are. So for example, let's say that sorry, I wanted to break apart a NIF. Well, obviously a NIF has certain data points that define the shape of that object. I would need to know the language for that. What is it called? Like a ninode? What does that mean? So once, because programmers usually have a tendency to under-document things, but oftentimes we document things while we do it because, God, you know, who knows, if you have to go back in and edit the code, then you're going to have to quote, digest all that all over again just to figure out what's going on. And that's very time-consuming. So it's easier to kind of give variables names that mean something, like an accounts payable. You know, you could put like the variable could be called money in, money out, money owed. And then therefore you could look at that and say, well, how much money's coming in? Well, all I got to do is look at the variable money in. So it kind of makes it makes the code more readable and easier to understand. So sometimes they will put this kind of stuff in here like 9-node, BSkin, have no idea. Alpha property, I'm assuming that has to do something with transparency. Scene root, see, these are all things that mean something to maybe an animator or a 3D modeler. So you got materials. So these are things where you can easily write an application that checks all this stuff. It gets all the file names conceivable and then says, okay, is anything missing? And if it is, then you can say, and even a mod, it'd be a good tool for a mod author to have, to say, yep, you know, this file's missing. So you didn't include this in your package. You can even do what another guy did. He actually loaded up the texture files to see if they're divisible by 2, things like that, to see if it's even a valid texture file that he was saying could cause crashes. So it's very, very simple things you could do, and literally a user could run this against their game, and then it would report any potential problems that they might be aware of on a data level that a programmer can very, very easily check for. So once the programmer spends, let's say, a couple hours writing a simple, quick and dirty app to do this, or even do one step of that, then from that point forward, it's available for everyone to use anytime, over and over again. In the application that I put together, you basically take a text file and you tell it what, because I'm not a really big fan of going in and constantly making program changes. Like for example, like the one that I wrote, let's say it looks for DDS files, like DDS extensions, and somebody's like, ooh, I want it to look for NIFs. Well, that means some programmers would go back in and have to change their code, recompile it, and that's too much of a hassle, and that makes the user too dependent on the programmer. I think that's unfair. So I just create a text file, and then the user puts what he wants to find in there, and then that's what the program returns. So later on, if he wants to expand his search for, let's say, material files, then he just puts that in a text file, and it'll also find BGSM files. So that's kind of like how that works. I just want to show you guys that, and just kind of pass that along. So just let me know what you think, or if you need anything else, and I'll see what I can do to toss it up. Have fun, and definitely enjoy gaming, because goodness knows there's nothing more fun than being right in the middle of a firefight thinking I got this, and next thing you know, you're looking at your desktop. Wonderful process. Wonderful.